to a suitable frequency, something unusual happens. Once the blue liquid is fully upside down, it stops dripping. The vibrations prevent the droplets from forming and keep the whole bottom layer of the liquid nearly flat. And if the droplets can't form, the liquid can't fall. It's floating on a trapped cushion of air contained by the glass on either side. It's compressing the air below it, but it can't displace it.
So gravity really doesn't have nothing to do with it. And watch this boat fall downward. Fall upward, I guess. It's relative. It all has to do with equilibrium. And she mentions gravity, but she also mentions equilibrium. To me, everything works on equilibrium. But watch this boat they put in there fall upwards.
So it hovers in place. While this was already known, researchers in France have been exploring another, even more counterintuitive effect of the shaking. When they place a boat or a light plastic ball at the bottom surface of the liquid, it floats in place, just like it would at the top surface. This is partly because the air pressure underneath the ball is quite high, since the air is being compressed by the weight of the liquid pressing down on it. But as you go up the liquid layer, the pressure decreases as there's less water above it pushing down. This results in the ball or boat being pushed up by the pressure underneath.
So that really has nothing to do with gravity, but they'll try and give you the math and say, well, because of the force pushing down, then things push up. They insist that there has to be a force one way or another, when in reality, everything is relative to everything else, especially with density. They don't talk much about things falling like faster or slower at depth and deeper. It's just so much they don't talk about, so that's what I'm exploring here. So I ask another question. Can liquids be compressed? And it's going to say blah, 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 blah. And then at the end it says, so liquids can't easily be compressed. And what's funny about this is a keyword question. So somebody actually asked, can liquids be compressed, yes or no? Because even Google, look, you can't get a straight answer out of Rumpus or out of Paid Nest Shill. And you can't even get a straight answer out of Google sometimes, folks. It's like that's how you know you're over the target, if their explanation has to come with a side of bullshit. And it comes down to this. So, okay, it doesn't go well with their math. Like my last example, they have to, they want to include water as a fluid. They don't want to talk about it being a liquid. Okay, they want to talk about it being a fluid when you're talking about densities and all this. Okay, but if it can't be compressed, then there's no V. There's no volume. Okay, but I can make it less dense and more dense, but then it doesn't do well with their explanation in their math. Like in Anthony Riley's egg experiment. Okay, I'm not compressing the liquid. The volume's staying the same for the most part, but him adding salt, he is making it more dense, making the egg float. But the problem is that is making the egg move or accelerate, giving it a force. But they don't want density to be a force, and we know density is not a force, but relative density is a force because we can make things move. So there's a problem somewhere, and I think we're right over the target.
Water pressure depends only on depth, not the container shape. Here we have 3 containers of the same depth. The pressure at the bottom of each container is exactly the same for all 3 containers because they have the same depth, even though there's much more water in this one.
So this is part of my war on gravity. So look at these containers, okay? Now, what happened to the center of gravity, okay? The center of gravity doesn't apply here, and they have a long, drawn-out bullshit explanation here. But the point is that the pressure is the same, okay? Even though there's more water above the first example here, there's more water, okay? There should be more pressure, but there's not, because the pressure is equaling itself out in every direction, okay? So they're very careful when explaining their vectors and their different states of matter, like solid, liquids, and gases. They have to, when given certain explanations, they have to condense them into fluids, so their explanations hold water, no pun intended. But you look at this and you say that, the water, there should be more pressure in the first example. That's what your common sense is going to tell you, because there's more water in it. So why wouldn't it be if it was just gravity? So with problems like this, then they have to come up with more equations, okay, more bullshit, or more, more factors in their equation. So then they have to come up with like things like this. Then they have to come up with like a center of buoyancy, okay. You'd have in the center of gravity, center of buoyancy, okay. Well, we know that relative density is a force. And what I think they should do, the way they do their math, okay, is they start with something, and they start with basically a zero, something we could never achieve, yet they still start there. So if you cannot go down to zero in reality, like with temperature, pressure, and you can't go up to an infinite amount, a contrast of zero, a zigadillion, whatever, a complete absolute total, whatever you want to call it, an infinity. Why would they want to have one infinity and not the other? Okay, because they can never reach a maximum amount, or they could never reach the minimum amount. Therefore, they're fiction. Okay, and to me, your math is flawed right off the bat. Okay, or simplified, one or the other. In reality, there should be a zero, okay, meaning equilibrium, balance, okay, and anything less than that is minus, like temperature. The room temperature should be zero, and anything less than that is negative. Anything above that is positive. Same thing with pressure. The pressure around you should be zero, and anything above that positive, anything below that negative. And then we can reach reality. We can reach and measure actual positive pressure and actual negative pressure for what it really is. See, if there's no void, okay, same thing with density, I could understand that you would need a benchmark with pressure and temperature, a universal benchmark to make things easier. But to me, okay, relative density is a force, okay? We can make things move with it. If we can make things move, then that's acceleration. And if you have acceleration, then you have a force, okay? It's logic. It's basic logic. And they've found a hell of a way around it. But if you have no void, when I always say that, I don't know if you've ever heard me say that, but if there's no void, then there's no need for gravity. In other words, we've only went 7 miles down. Okay, if we ever went down past solids or molten liquids or whatever and reached a void, okay, then we need gravity. We need a downward vector. Or if we went up high enough and there was zero pressure or infinite vacuum, okay, then we'd need gravity. Okay, but seeing that there is no void, then we're always in a medium. So everything is going to react according to its density, and there's no way around that. There's no breaking that rule. Like if you put, even like there's things they don't talk about a lot. Like you put a balloon underwater, and you in a vacuum chamber half full of water with a balloon underneath it, and you start taking out the pressure, the balloon will expand underwater. So they'll say that some things transfer through water, or nothing will transfer through water except pressure, and they'll talk about everything that that doesn't transfer. They don't focus in on, that is just one of the things they avoid. They don't talk about things falling faster in a medium. Okay, they want to give objects terminal velocities, and they want to say that's the reason that it quits accelerating. Okay, I can understand. Okay, maybe something won't accelerate as fast in a medium. Okay, but if it is an actual acceleration, then it should accelerate. Even if it slows down acceleration, it should still accelerate. There's no getting around it. But I got more to come on this.